Hi, this is Kathy Keener here with Triflex. Just doing a quick modeling of a tutorial that we do in the training class. So if you have Triflex open, the first thing you would do to start a model is go to Setup, Modeling Defaults, and select your B311 or code. Now we have several. We have Navy, Eurocode, B314, 8, 3, etc. For this one, we're going to use B311. The initial node numbers are here. Notice that we have displacement stress range is a max difference amongst cases. That means if you have several operating cases, it is going to look at each of those. It's going to give you the max displacement stresses on each of those cases with your piping code report. Okay, so just getting started. We want to look at the cases real quick. They're real simple. I usually have an operating and installed. Notice that it says that all operating cases without occasional load will participate in a piping code calculation. So a cold sustained case is required for accurate analysis. In order to add a case, you would just go here. Okay, so I'm just going to accept that because this is a simple one. Let's pick up our anchor. It defaults to rigid. Let's assign a location, this button right here. Check that, and we can put it at origin. Okay, and that'll prevent it from jumping around. Something that we've actually improved on that. Our piping system here is 4 inches. This is the tutorial again that comes with the package. Standard wall, B311. Specific gravity is 0.85. That's like a sweet crude. A106, grade B. Insulation is calcium silicate, 2 inches thick. So we're just going to say thickness, 2 inches. We press tab and we have all our weights. So now we look around in each of these groups, pipe size, pipe material, insulation content, and we see these reiterated here, right? Ripple size, ripple content, ripple material, ripple installation. Ripple is our word for a blanketed change using a selection of some sort. You can go from the very first component to the last, or you can select components and only ripple changes on selected components. Okay, so now we have all of our specific weight and pipe information. Our base temperature here is going to be 70. Our operating pressure is 70 as well, 70 psig. Temperature is going to be 300. Okay, so now we have our operating data set. And again, we can ripple our operating temperature, pressure, base temperature. Let's go to our initial movements and rotations, because we're going to assume that this is attached to something that's growing. So you can either put the growth in if it's known, or you can put your temperature for your equipment. This is going to be 200F here. We're going to select just the A53 grade B or the A106 grade B. Let's do that. A106 grade B is fine. This one would have a true anchor below the offset. The offset is going to be referring to the nozzle. So we're going to say from the true anchor you have to go up 27 2 3/4 inches. And we'll say calculate movement, and we'll see that we have a positive growth in the Y of 0.2722 whatever inches. Okay, so we're ready to go. Let's do a pipe. We're going into the -Z direction, so we're going to pick up a pipe at the component toolbar. Notice that our component toolbar is anchor, pipe, elbow, valve, flanges, reducers, joints, expansion joints, release component. The release component is kind of like a C node. It's basically a component that defines the relationship between any two other components. Okay, structural is AISC. It's attached in the same model. There is no reason to go to a different viewing screen or anything else. You attach it using the release components because you have to define, is that pipe shoe stopping it in the axial? Is it stopping it in the guide? So you have to define the structural attachment using the release component. And then, of course, we have a PRV as well. So let's go in the Z direction with 4 feet 2 inches in the negative Z, so we need to change that. I'm going to zero out my X. We're going into the negative Z, 4 feet 2 inches. Also, we've got a spring hanger there. It's an existing spring hanger. So we're going to go from our pipe data tab over to our restraints tab. See that? We're not going to say size of spring hanger. We're going to say existing spring hanger, in which case we only need an installed load, which is 400 pounds, and a spring rate, which is 168 pounds, telling us that that's a variable spring. Okay, and press OK. Now we can press escape. Notice that it defaults to a selection mode. Up here in our graphic toolbar, which is to the right of our component toolbar, you can switch it back and forth from selection to rotation. Now you can press escape as well. The escape key toggles that as well. So when we do that, we can just adjust this just a little bit and we can see that. But we want this view here, so we can either just press the left key and on the mouse and do like this, or we could go over here to the graphic toolbar and we could say orient view with the red arrow, set up isometric, and we can set that up as we want it. Say that we want a positive Z over here and an X over here and a Y up. We can do that. Press OK and press OK, and there's your isometric view. Okay, so now we're going to grab another pipe and we are going to go 6 feet 4 inches. So I'm going to use the absolute length because we have not changed directions. 6 feet 4 inches. And then we're going to go down in the negative Y. 3 feet 11 1/4 inches. Okay. Now that's going to be treated as a stanchion, so we might take the temperature off of this. So I'm going to take the temperature off of that and make it 70 to 70. Base temperature 70, operating temperature 70. And that's on the process tab, right? Okay, and then I'm going to slap an anchor on this. So I'm just going to grab from the component toolbar a rigid anchor. No need to assign a location. This anchor over here is assigned a coordinate axis, so nothing's going to be jumping around. All right, and then our next component is actually a combination of an elbow with the preceding pipe. So we're going to grab an elbow from the component toolbar. It's going to go from the from node to the tangent, and from the tangent to the next. So we just basically have to give it a direction and then meet at least the minimum length required. So for a 4-inch elbow, we're going to need at least 6 inches to get out of it. That's our minimum length. In this case, we have a preceding amount of pipe, so we're going to put in 4 feet 3 inches and 3 sixteenths in the absolute length there. I'm sorry, we're coming from the wrong place. Let me cancel that. You have to make this current. And that's a good way to figure that out too, because you want to keep going in this direction. So you want to make this component current. The red means current. All right, so pick up an elbow, and again go to our absolute length, 4 feet 3 inches and 3/16. And it's going to go into the positive X direction, so we know we have to have at least 6 inches. So we put in our minimum length required right here, 0.5. Now we can put a large number there too as well. It doesn't matter because really we're just telling it where to go. Okay, we're creating a vector. And so there you have your elbow with the preceding amount of pipe, or our combination component. Now let me turn on the node numbers for you. On the graphic toolbar, we took a look at selection. Of course, the binoculars are how to find a node number. The line rendering is this. You know, you're just going to go from line to a rendered graphic, right? Underneath that is node numbers, and we can click those. Now, node numbers can be changed under Setup and Graphic Preferences. Okay? All right, so we need to come out of that elbow from the tangent intersection point with a pipe. So that is going to be headed in the X direction and positive X, and it's going to go 4 feet. Okay? Now also, we also have a simple support on there too. So let's open this back up, go to the Restraints tab, and put our plus Y, which means that the support is acting in the plus Y direction. So that's right here, plus Y on the Y-axis. Okay? Now we're going to go in this direction, that's the minus Z again, with a pipe and an anchor. So we're going to pick up a pipe, head into the minus Z with 5 feet, 2 inches, and 1/8 inches. Okay, 0 out, and then we have our pipe here. And we're going to, again, put an anchor there. All right. Now we're going to go back in this direction in the positive X. So we want to make sure that this is current again, right? So we have here a valve with a preceding amount of pipe. You can very well model each component separately. This is just an attempt to show you what can be done to save time, or perhaps if you have an isometric that is dimensioned in a particular way, you may need to change things up, right? Okay, flanged gate valve, 150, weld neck flanges. That's what we have on our diagram, the tutorial, PDF that's included with the installation file, and it's also in the it's under samples, and it's also in the manual, tutorial manual. Notice that we have a flange on both ends. You can see here that it's a flanged valve, not a welded valve. So flanged gate valve 150. You might have to change your weight for valves. If you have an operating weight, you can do that. If you have something that has an offset operating weight, I would model my valve as joints. So, and we're asking for flanges on both ends. We have a minimum length here that has to be met because we changed it to a gate valve. So we just want to say use minimum length, and notice that that says that. But we also have a preceding amount of pipe. So we're just going to say absolute length, 5 feet, 10 inches, 1/8 an inch. Okay? And there you have it. Then we have another pipe. Same direction. 3 feet, 3 inches, and 3/8 of an inch. And then an anchor. Okay, now let's say we messed up. We wanted to delete this this section here. Now we can do one of two things. We can delete a component, or we can delete a branch. Now, in order to delete, you don't want the component to be current, which is dark red. You want it to be selected. So we're just going to say Control left click will get us one component, or Shift left click will get us the branch. Now we're going to go back over to the graphic toolbar, and we see that we have some black squiggly lines under the F, which is Freeze Graphics. And if we press that, we can see exactly what we have. It shows selected. So we can see exactly what we have selected. Show selected. Okay. Now, if we had this selected and we press the delete key, it is deleted. We go up here, we press Edit, Undo, then it is back. Now, I'm going to deselect this so that I don't accidentally delete it. So I'm going to say Edit, Deselect All. Okay? There are several other ways to select. For instance, you can do a box selection. Also, you can use your input graphics here under Graphic Display. See the cantilever icon? Graphic Display has your inputs parameters here. You've got your pipe properties, your process data, where you can pull down the bar and say temperature, pressure, and select by any of those. You can select by your pipe schedule, wall thickness, pipe material, insulation, and it allows you to, and the pipe size, of course, but it allows you to look at any of these and check your input data, which is very, very handy. Triflex was the first one to come up with these colored graphics and this way of showing things and allowing someone to see their input data this way. And it took many years for the competition to catch up. So you can, let's say that we only have one size pipe. Let's see, we only have one temperature too. We don't have a lot that's interesting on this one, do we? But let's say that we had two different size pipes. It would say number of different items 2. We would press OK, go right next to the cantilever and use the color scale. And we would have 2 pipe diameters rather than 1. We could hover over it, press Control, left click, and it's going to highlight or select each of the qualifying components. Okay? And that is the way that we can just grab in here. Say we wanted to change the temperature, we would go to Process, and we had a portion of it selected rather than all of it selected. Then we could just change the temperature. Ripple this case is very important. You have to say ripple this case. And then we would say ripple selected components. Okay? Edit, deselect all. Copy and paste is very easy as well. It's under Edit, Cut, Copy, Paste, Merge Pipes, Interchange, Renumber. You can select by the component type, which comes in handy. In the lower left-hand corner, it's navigational, but there's also, you see that we're on the append mode here, but we can also replace components here. That comes in very handy. And we can also insert a head of a component. Okay, so if we press Save here, we'll get rid of that coloration, but I haven't saved anything yet. So let's see, I'll just put it here. Tutorial, August 26th. Okay. I'll put it here, and then now I'm ready to save. Now in the right hand corner you'll see the word OK. It's checking our geometry in real time. So as soon as you make a mistake, it's going to say ERR. Now if you leave an elbow without coming out of the elbow, it will also say ERR. In the upper right hand corner, or upper mid section up here, it will say error or warning, and it'll tell you what's going on. The green arrow will be green if the geometry checker is okay. Press that. You're looking for normal termination or calculation complete there. Output, view analysis results, pull down your reports here, right? We have a piping code report. Notice that it's a little bit extended because we're using that max displacement under setup and modeling defaults. So if you have several operating cases, you're only going to see the expansion stress in this case, because we're in B31.1, and you're going to see it as the max amongst all the cases. Okay, if you uncheck it, you can see each individual operating case and see what each one is doing with the displacement stress range stresses, or otherwise known as your expansion stresses. Okay. We separate out the sustained stress, the pressure and weight. We can see that that's 12%. This is now, if you notice, I'm double clicking a couple of times to get the descending order. Okay, I want to see the max, so I'm double clicking on this column header to get the descending order. Let's take a look at that graphically. Now, normally I would always instruct people to take a look at the movements, make sure that the movements are in line. They are. Take a look at your restraint forces and moments report. Make sure that these are reasonable, and they are for the pipe size. Anchor forces and moments. What do we have? 4-inch pipe. So you can see there's some issues here. With some moments, right? Node 20 wouldn't pass if it were equipment. But let's go back and look at our graphic by pressing the graphic display, which is the cantilever icon. Now we have more tabs. We have the calculation results, where we can see our deflection, and we have our piping code results because we looked at the tabular results, right? And we can pull those down, and we can show our expansion stress percent and our sustained stress percent. But let's look at our deflections, because that's going to tell us quite a bit. So it defaults to a resultant deflection. You have to remember to press Show Centerline Deviation. Press OK. We can adjust that just a little bit. Let's adjust it just a little bit more by using the scale here and refresh display. Press OK, and we're going to press escape so that we can get our rotation. So we're going to do this. Okay. We can also do the color scale icon right next to it, and we can see how much that maximum deflection is for this case that we're on. Okay, because of course deflection is relative to the case. All right, so you can set the thing to spinning if you want, but you can see with this one we have a problem because this is quite a rigid branch coming off here. Let's take a quick look at our T's. We did have one that was a fabricated T. Now, under modeling defaults, setup, modeling defaults, we are using automatic calculation of stress intensification factors for a T, and that's defaulting to a welding T. Now, we can make it default to a fabricated T, welded lead, or whatever we want. This means that whenever Triflex sees a natural T formation, it's going to apply stress intensification factor. So for instance, if we go over here, we can open up our pipe and we can see stress intensification factors, and it's applied a welding T. If we want to change that, we can say user, or we can say code and pull it down. Now let's go to the other one where we had a fabricated T. open this up, and that's going to, of course, drive our stresses a little bit higher. So we're going to say code, click this, and go to a fabricated T. And so notice that our numbers changed. If we press OK, it's going to apply the stress intensification factor to each of the connected nodes. And the stress intensification factor is required, of course, by B31 ASME codes. So save it, and like I did here, press OK, and run it. And that's how you are going to get results. Now, when you get ready to see the output or report or something like that, you can go to Utilities, Export, Export to Excel, All Components, and it'll show each of the reports that you select in a Excel spreadsheet. Okay, I think that's a fairly good introduction. Thank you.